So now in this video, we're going to take a look at series capacitors. So we're going to compare them to an equal value capacitor that is by itself. And the main thing we're looking at is its equivalent capacitance, because it is a bit confusing. So we have 20 volts across this these two circuits right here. So they're independent of each other. And we have a single 470 microfarad capacitor there. It comes up to the line lead, the anode of the LED, as that does that jumper right there. And then short lead, the cathode, comes down one, comes to the resistor. So I know it's a little hard to see. This one's a bit easier to see up there. Same layout, but we have two capacitors in series going from there to the negative rail right there. And that's a 4,700 ohm resistor protecting the LED. For the most part. So the capacitors charge instantly and current starts flowing through the LED and resistor equally when we have that jumper plugged in there. We can look at the current being provided. So that's 7 milliamps. That's for both of these circuits. And other than these two be wired in series, which doesn't really matter, they just get a charge. But after they charge up, then they don't do anything. So the current's going through there probably 3.5 milliamps and then 3.5 milliamps through that LED. So not a lot of current. They're not horribly bright. But now, the main takeaways. We got these two in series. Let's yank, without me blocking the LEDs, the jumpers at the same time. And now they are being powered by the capacitors. And you can see the two series capacitors, even though they're the same value as the lone capacitor, the LED went out quicker. And so now the capacitors are mostly discharged. So let us look at first. We just saw that they basically have, it looks like, half the capacitance, which is what they should have. So before we look at that, let's look at one of the pluses of putting capacitors in series. So now I got the multimeter ready. We'll set it to measure voltage, and we're going to turn the output of this off. So we got the power button, and that turns the output off, because when we attach these wires we will get a sudden connection, and at 20 volts we get a spark. So I'm going to put it to the positive rail and then up to where the capacitor and the anode of the LED connect up there. And that's what will charge it, the capacitors, and also get the LEDs to light up. So I have it up where the anode of the LED there is. I hit the power button, as you can see there, and suddenly it turns on. And we got the current there. Looked like it might have noticed a little bit more as the capacitors charged. But in case, first we will look at the voltage across the lone capacitor right there, and it's 20 volts, the power supply voltage. That's what we expected. Now we'll come to the series capacitors. So we're going to the negative side of that one and the positive side of this one, and there you can see 20 volts. So far that may not look terribly interesting, but that's 20 volts across two capacitors. So I'm just going to kind of bend this so you can see the wires, and hold it there. We're going to go across this lone one. Now you see it's 10 volts. And that one is 10 volts. So the voltage is split up between them. These can handle 50 volts. So we're nowhere near our limit here. But if these were only rated for like 15 volts, this one would have exceeded its rating, whereas these only have 10 volts across each one of them. It would not have. So that's why you normally use them in series. Now they have half the capacitance, unfortunately, and so if you needed half the capacitance and your only way to get that was two capacitors in series, you could do that. Now another thing is, we're going to look at the voltage again and pay a little more detail. So 10.03, and that one's 9.9. So as you can see, it doesn't automatically split the voltage equally. And we're going to turn the power off and let them discharge. and so there was some capacitance in the power supply, I think, and they're still connected with the wires, so they discharged evenly because the capacitors are all connected. That one there is connected to the positive rail, and that one's connected to the positive rail, so we got an equal discharge. But in case, we're going to look at the voltage across this capacitor. I have the probes. No, that's the power supply. When you turn the power supply off, it has a negative voltage, so that's kind of bad. So let's turn the power on, and so there you can see a voltage. I should have thought of that. We got the voltage. Now we'll just yank the two jumpers and get them out of the way, and you can see them discharge. Of course, the 2 series ones discharging faster. And now, that's one thing with this power supply. When you turn it off, you turn the output off, it gives a negative voltage, and so that's something to prepare for. But in any case, you can see we have a diode drop across this capacitor because the diode needs about 1.5 volts, and there's probably leakage that is draining this even further right there. Now we will go over to the 2 of them, and we should have that same diode drop, but again, we have half the voltage there, and so let's get in more accurate. 0.705, and that's a 0.736, so not too bad. But you notice if we went all the way to 0, one of them would probably be a little bit above 0 and the other one a little bit below 0. So that's one thing. If the worse they are at charging evenly, the worse one of them is going to go to negative if you drop the 2 of them to 0 volts. So you should have protection circuitry. In this case, we have the diode, that the LED, I should say, that keeps them going from going all the way to 0 volts. So we're pretty good right there. And finally, we really don't need to do experimenting like that. You can measure capacitance with a capacitor. So I just yanked out the LEDs and the protective resistor. I unplugged the power supply from the board completely, and so we're going to make sure they are completely discharged, and so we can just go directly, make a direct connection and completely discharge them. You want to completely discharge capacitors before you measure their capacitance with a meter. That is very important. So that's what we're doing. We're making sure they are at 0 volts, and the 0.7 volts that these two are in, the 1.5, maybe won't be too bad for the meter, but it's best not to take any chances. That's not a terribly high voltage. So they are in series again, and we're going to set the meter to measure capacitance. Pretty straightforward, and this may be my best multimeter for measuring capacitance. I do have an LCR meter, but this one does pretty good. So takes a little while. There you can see they're 470 microfarad capacitors, but we don't expect the accuracy of resistors. Capacitors tend to be more inaccurate from their rated value than other components. But in any case, there you can see that's still pretty close to 470. So I'm bypassing that one. Even though they're in series, the meter is directly across one of them, and there's no other path for current to go other than the meter right there and the single capacitor. And we go to this one, and we'll see again pretty much 470, and it's almost 500, but it's close to 470. Now we go across the 2 of them because they are in series, and there we go. Finally, we got about half. So that's the 2 capacitance put together basically and divided by 2. So that is half the capacitance of both of them. And so there you can see, you measured it there. So it's confusing at first that the capacitance is split up. It's easiest when they are equal value. Then you got 2 in series, that is 1/2 of the capacitance. If you have 3 of them in series, you have 1/3 of the capacitance. So we got 3 of them in series right there. And what will it be? I think about 1.5, I believe, or 100 and not not 1.5, but about 150. So it's a little higher than 150 right there. And microfarad. So that's 1/3. And of course, we go up here. So, in any case, it's really easy when they're equal value. The capacitance go down. Again, it's very important that they stay balanced. And so, that's a pretty intense topic, actually. So, we're not going to get into that too much. But you got to be careful with series capacitors. And it really doesn't come up that much. The biggest chance I'm going to really be seriously doing series capacitors are my super capacitor videos, because they can only be charged up to 2.7 volts, which you can't do much with 2.7 volts. So you got to really put them in series for the most part. And then you got to make sure they stay balanced, that they charge evenly and they discharge evenly, and none of them get reverse charged and none of them get overcharged. And so with these, it's a lot simpler, not as big of a problem, but super capacitors are. So in any case, hopefully you still enjoyed the video. Thanks for watching. I will see you in the next video.